Organizations today are challenged with a variety of customer communications and correspondence generated across a number of line of business applications and data types, such as PDFs, AFPs, XML, and line data. IBM Content Manager OnDemand provides a single governed archive for both internal and external users, delivering through a number of channels such as mobile, desktop, and traditional mail. Over the years, we have seen clients increase their adoption and in some cases shift away from the generation of traditional print streams such as AFP and choose PDF as the archive format of choice. Through the following lab, I'm going to show you how quickly we can configure a new PDF stream to load into IBM Content Manager OnDemand, ingest the stream, and lastly, the storage savings we will get. So let's begin by looking at our sample document. It is a 160 meg PDF stream that contains roughly 3,800 statements across 14,000 pages. But for our purposes, we really care about is what the document looks like under the covers. Once inside the document, we're looking for piece info tag that represents the page piece dictionaries or PPDs, or simply put, the indexing information for the statement. We see here the account number, the bank number, the client name, the branch number, and statement date. When we load this document on demand, we'll map these index values to the matching data fields in the data model that we will define. We're going to use the report wizard to help us define the new load type called application. The wizard is going to help save some configuration steps, but will still require a few final configurations at the end. I'm going to skip ahead to those configurations. We're going to open our application definition we just made called one PDF and update it. We'll modify the indexer information because we're using PPDs. We'll delete the coordinate information because, as mentioned previously, OnDemand will read the PPD values embedded within the file. So the only indexing parameters we require are res type equals all, which means collect the PDF resources, index start by equal 1, meaning start indexing at page 1, and lastly, index mode equal internal, which means we're going to look inside the document for those PPD index values. Okay, now that we've configured OnDemand on what to expect from an indexing standpoint, we're going to go ahead and run the indexer against the print stream. As a reminder, this is a 160 meg file, so it's going to take a few seconds to load. We'll skip ahead to that load is complete. Now that the load is complete, let's review the results. We found 3,840 statements. As a reminder, we had a 160 meg input file as shown here, which stored to about 29 megs shown here. That's really resulting in about a 5-to-1 compression. Okay, as a final step, we're going to view one of our sample documents. We've logged into IBM Content Navigator, our out-of-box thin client. We'll perform a wildcard search here for our statements we just loaded. We'll select and view the first one here for Dale Dalton. And as you can see, our 4-page PDF has loaded beautifully. As a last step, we're going to download this document. As you can see here, it will download at about 3 megs. And this is a key point to understand. Let me explain why. A single print stream file contains hundreds of thousands or millions of individual correspondence. OnDemand can parse through that file and extract out the indexing information embedded in the PPDs or page piece dictionaries. When OnDemand goes to store the print stream, we extract out the resources such as fonts, images, and page overlays, then compress the remaining document before archiving it, resulting in sometimes in an over 100-to-1 compression versus storing individual PDFs in a traditional document management repository. PPDs allow for rapid ingestion as they are non-viewable tag elements within the PDF where we can embed our indexing information as a name-value pair rather than looking at coordinate information for the indexes. By storing a print stream rather than individual bursted PDFs, we are able to take advantage of the optimization inherent within OnDemand. In particular, the way that we are able to manage the resources as well as compress the stream. Looking at our sample, if we stored 3,800 statements individually into a file system or traditional document management repository at 3 megs each, it will have taken up 11.5 gigs. We showed the single print stream starting at 160 megs before being loaded into on-demand, getting compressed at a 5:1 compression ratio, storing at only 30 megs in on-demand. So if you compare the 11.5 gigs to the 30 megs we stored in on-demand for the same set of documents, it will result in a 397 to 1 compression. That is a dramatic savings. Here we're only showing 4,000 statements. How many customers do you have? 400,000, 4 million, 40 million? So you can see how the savings grow exponentially when compared to storing those documents in a traditional document management system. And there is one of the true strengths of IBM Content Manager OnDemand. Thank you.